Hello and welcome to this video. This tutorial is about a short introduction to version control systems with an example use case of Git. Version control systems are primarily software engineering tools and have a huge wealth of facilities. Here, we only highlight those that are most useful for researchers who are intent to share and maintain their research code. Let's get into it. What is Git? Git is a distributed version control system that helps maintain large code bases with multiple developers. Not rare that these repositories have millions of lines of code with hundreds of developers working on the same code base simultaneously. Git is free and open source, has a quite tiny footprint, very good performance, and relatively easy to learn. And it is available for most platforms, macOS, Linux, and so on. Primarily, it is a command line tool. All the documentation can be found on that web page and have multiple platforms that based on GitHub, on Git, for example, GitHub or GitLab, but many more. It is primarily a command line tool, but you can also use some UI tools as well to help you maintain your repository. For example, Source Tree or GitHub Desktop, but there's plenty other tools for this too. Git has a very nice IDE integration for most of the most popular IDEs like Visual Studio Code, PyCharm, CLion, or Sublime Text. If you want to find out more than this tutorial, you can read the official documentation. You can find a quick tutorial for mostly of these facilities that we will cover in this video, and you can also access a cheat sheet if you forget a command. Okay, but what is a version control system? So let's say we have a remote repository somewhere in the cloud or an institutional server where we have a so-called version database where we store all our source codes. In this version database, multiple versions of the code exist, mainly historically, but in different branches that we will cover later in this video. Now, developers can clone or copy this version database to their own computer and work on source codes locally, even on a single file or multiple files. Multiple developers can work on multiple files or a single file as well. The point is that all happens on their local PC. So let's see how Git works, and this is really just a short, brief version of this. So the first step is to create a Git repository on, for example, GitHub or GitLab, or you can just create one on your own machine as well and later upload it to GitHub or GitLab. The second is to clone to your local machine, given that you are created initially on a remote repository. Then make changes, edit files, add or remove files, or just move files to another part of the repository, and only locally for now. The fourth step is to commit your changes or stage your changes for upload, and then push to the remote repository or update the remote with your changes. Let's see one by one. So the first step is to create a Git repository. This is usually quite straightforward as the platforms give you a quite good user interface where you can easily make a new repository. You just need to decide which platform you are intent to use. Would your repository be public or private? And some other settings that we are not covering today. The second is to clone this to your local machine with the git clone command, given that you have the URI already. And this will download all the files and initializes the local repository. Well, initially we won't have much files, but still it will initialize the repository on your local machine. The third is to make changes locally, so edit your files, add new files or remove files. It's completely up to you. This is how it is happening. But the important thing is that all of these changes are only happening in the staging environment, or so to say, in your local PC. It will not save locally. It will not save remotely, only locally, in contrast with, for example, Dropbox, where you can have an automatic synchronization with the cloud infrastructure. The fourth step is to commit the changes. So let's say you are happy with your source codes and your files, and then you commit. Usually these commits follow some sort of logical order, meaning that let's say you want to add some functionality to your code or add new files. So extend your source code with one function, and then you need to add another file to make this function work, and you commit these all together into one single commit. It is important to list all the files in the commit, and presumably it would be ideal to have some informative message with your commit. Okay, you also need to commit all the changes for added or removed file as well. So if you remove a file with the git rm command, you need to commit that file to have the change staged. And finally, you need to push changes to your remote repository with the git push command, and this will upload all the changes to the remote repository. There are some useful utility features of Git. The first one is the git status command. This will tell you about changes staged, or if the local repository is clean, and so on. We will check this as well. Showing changes with the git diff command, this will list changes in the staged files. So all the edits you made in your files, line by line, will be highlighted in the output of this command. And we can also use the git log command. This will list changes in the repository or some sort of history list of the commits that happened in the repository. Okay, now let's do a short demo where we go on these steps one by one. All right, so we are now creating a new repository in my GitHub as an example. So let's give it a name. Let's say git tutorial. Give a short description. Choose the visibility. So let's say it's public or private. I choose private now. And we add a README file just to have an example source code initially. The rest we leave as is because these are advanced features for this first video. Click on create the repository, and you can see it is created here in my private space. You can clone it to your local machine by clicking on this code button and just copy this address or URI to your clipboard. Let's clone this repository with the git clone command. It will ask us a passcode. You can see that it is now downloaded to our local machine. You might want to add an SSH key to your GitHub account before you can clone or push changes to your repository. This can be done following the official GitHub documentation on how to create SSH keys and how to add these keys to your GitHub settings. Now, let's make some changes in our repository. So first, I will just edit the README file. I will use Vim, but feel free to use any text editor you wish. And let's say that we want to change this README file. So just add some content. Okay, save the changes. And also I will add a file to the repository. So I added this hello world file to a repository, which is just really a simple Python script that prints a hello message. We can test it. It is working. Okay, now we added a new file and changed the README text, but it is still not uploaded to the remote repository, so we need to commit and push these changes. Before that, let's check the status of our repository. So what we can see is that we are on the main branch, which is good. I will explain later why this is important. We modified one file, which is the README file, and we have one untracked file that is the hello world Python script. So in order to make this tracked, we add it with the git add command. And if you check the status again, you can see that we have a new file here, hello world py, and a modified that is the README. Also, we can check the differences between the files. So you can see that we only can see the README change, the differences in the README file, and you can see that these two lines are extended with some new content, or let's say changed with some new content. Okay, this is nice. So what we need to do now is to commit our changes, listing all the files we want to include into this one single commit, and leave a message. Let's say initial commit of the Python script. Okay, and now in order to make changes on the remote server, we initiate the git push command. We provide our password, and we can see that it is uploaded to the server. If we now check the user interface and refresh the repository, we can see that the README is updated and the Python script is uploaded. This is great. Now let's explain what is going on. So we have 4 different states of a file. One is untracked, other is unmodified, modified, or staged. So untracked files, for example, the hello world Python script initially, when we just copied to the repositories folder, was untracked, and we should add this file for staging, and it became modified. obviously it became modified because it's a new file, haven't existed before. We can change or edit files that is already part of the repository, so it became modified from unmodified. And then we can stage the file for commit or for uploading to the server. We can also commit the file, so when we, let's say, close the changes or finalize the changes, we move all the files from the staged state to the unmodified state. And we can also remove a file from the unmodified state or any other state to become untracked, or remove the file from the repository entirely. Great. But there's more, namely branching. It's a very important feature for software engineers. And what is happening is that it creates a copy from your main branch. As software engineer, we use this daily, as all new features or all bug fixes or minor or major changes are happening on different branches, different than the main branch. So we work in this branch, make edits, creating new files or removing files. And while we work on this branch, the main branch remains the same. So how to do this? So we can create a new branch with the git branch command, stating or giving a branch a new name. But also you need to check this new branch out with the git checkout command. The git checkout command works for already existing or previously created branches too. So this will create a new branch from the main one or any other branch, if you will, leaving the original branch unchanged. So let's see on a small figure how it works. So let's say we have a main branch, and this main branch is in some state containing some files and some source codes. Let's say we have a good idea that we want to test, but we don't really want to mess with the main branch because probably we are happy with how it is working now. So we just want to experiment a bit. So we create a new branch and start working on that branch, making changes, edits, adding files, and so on. But in the meanwhile, we can still work on the main branch because these branches are completely separate entities. So we can work on the main branch, or we can also make a new branch from the already created good idea number 1 branch to experiment more. And so we can continue working. We can make a third branch from the main, or a second, third branch, really in any combination. It can happen that this recently created branch proves to be a bad idea. It's okay, you can just discard it, or you can delete it from GitHub entirely. At some point, it can happen that this good idea proves useful and proves important. What you can do is you can merge it into the main branch. That is completely optional, so it's not mandatory to do that. As you can see on the good idea number 2 branch, it just exists there without merging to anywhere. And you can then continue working on the main branch after merging it. So what is going on? These branches are all completely separate code bases. So these are completely separate. If you start working on one branch or continue working on another branch, the rest will remain intact. You can create new branches and you can merge branches however you wish. Important to note is you need to commit all the changes to the new branch as well. So just as we did before, you should do the same for these branches as well. except you need to select which branch you want to push your changes to. So let's go on. Don't forget to commit to the new branch with the git commit option and the usual options, and push the new branch to the repository. It is important at this point to state which branch you want to push your changes to. So when you use the git push command, you should say -u origin and the branch name. This will save the new branch in the remote server with all your changes. Okay, and let's try this. Create a new branch from main, make the changes, and when we are happy, we merge it into the main. Okay, so here we are. Let's say we want to create a new branch called updates. We need to check out this new branch. And now all the changes I make will be on this new updates branch. So let's say we just want to work on this Python script and just, let's say, adding a small edit into the code. Let's see the differences. You can see that only this hello world Python script has changed with some small edits. And let's see the status command. And now the status of this repository has been changed, or it's a bit different. You can see that we are on the branch updates. Before we were on the main branch, now we are on the updates branch. And we have only one file modified, that is the hello world. It is quite important to check which branch you are working on before you commit or before you push your changes, because that will affect how your repository will look like later. So all the time before you push, check which branch you are on if you have more branches. Okay, now we are on the updates branch, so we are ready to commit our change with the usual method. Let's say we have some minor improvements. And what is important is to push your code to this updates branch. Type our password, and it is updated with a new branch on our remote repository. All right, let's check this new branch on our server or on GitHub. So you can see that this is the main branch. If we check how hello world looks like, it's still not changed. So on the main branch, the Python script looks as before, so it hasn't been altered. But if we go back and select the updates branch, you can see that this branch is one commit ahead of the main. That is expected. And the source code is different. So this is the extended source code. Great. Now what we can do, and this is completely optional, is to merge this updates branch into the main branch. What we can do is to click on this compare and pull request button, and you can set a title, add some description on this merge operation, and also check what differences be made during this time or during these commits you want to merge into. Okay, if you're happy, click on the create pull request, and this pull request will test if the updates branch can be merged easily into the main branch. And it is expected because we haven't changed the main branch since we created this new updates branch. So we are not expecting any problems. And you can see that no conflicts with base branch, so you can just merge it. And if you click on merge pull request, it will create a merge. And if you check back the code on the main branch, you will see the hello world script will be changed to the new content. Obviously, this merge operation can be done on the command line interface, but I usually prefer this UI as it is a bit more straightforward and easier to check if there's any problems or any conflicts. There's another quite useful feature of Git, which is tagging. Tagging is essentially naming your commits. All the commits has a name, which is a long hexadecimal number that you will probably won't memorize. So let's say you want to tag a stage or tag a point in your workflow. You can use this git tag command, and you can choose any name you want. For example, git tag v0.1 or really any other name. And you should also push this to your server, which is the git push origin -- tags command. Okay, so let's do this again. So we are here on the main and have some nice state we want to use or we want to refer back later. We can add the name. So let's say this is version 0.1. We're working on it, making changes. And at some point we want to say, okay, I'm also happy with this. So let's say version 0.5. And then work again, continue work and version 1.0 and so on. You can do this on any of your branches. So we have a lot of branch and we have the main and so on. So what you can do is you can also tag any branch, any state, any commit in your repository. Okay, and let's try this. All right, so we have a nice state. Let's check where we are. Okay, we are on the updates branch, but I want to tag the main branch. So what we need to do is to check out the main, so switch to the main branch. But it is important to update the main branch with the git pull command. This will pull all the changes since the last update. Enter our password. Okay, and if we check how the hello world script looks like, we can confirm that it is the updated recent version. So we are happy now with this state, and I want to tag it with the git tag 0.1 name. And since it is tagged, we can push this to the remote repository. Great. If we check now the repository, we can see that we have a new tag here, which is the 0.1 tag. So we now have branches and have tags. And if we select that, we are in that 0.1 tag. And we can select this tag on our local copy as well. You might ask yourself, what if you mess up? So actually, all these repositories and all these code management tools and version control systems are some sort of a fail-safe. So if you make some mistake or delete some version of the code, you can easily roll back to a previous state. So let's say we have these nice tagged version of our repository, but at some point we made a mistake. So we made changes, made edits, added new files, removed files, and commit and push. And we just realized that, okay, something went wrong. Maybe I deleted a file that I didn't need to, or I pushed to the wrong branch. There's facilities for that. So what you can do is to go back to a previous commit, the previous commit, or any other previous commit in the history of your Git repository. So this is a tool for somewhat undoing things. So just to go one step back, you can use the git revert head command, or if you want to go back multiple steps, you can use the git revert and the commit id command. This will create a new commit with appropriate changes, so you won't delete your false step from the history, you're just making changes so it would appear that you are in a previous step of your repository. After you did this, don't forget to use the git push command again. Alright, let's see how this works. Before that, we can use the git log command, where we can list all the changes we made and list all the commits we did in the previous steps. And you can see that there's a commit ID for all the commits we made previously, which is a huge hexadecimal number. So you can see that this is the initial commit when we created the repository. This is when we uploaded the Python script, when we made some minor improvements from a different branch, from this branch, and also some minor improvements when we merged this pull request, and then some other updates. So let's say we just want to move one step back, and we can say git revert head. You can also substitute this head with the appropriate commit ID. And you can see that we reverted some updates commit. So we reverted the commit with the message some updates. And this is also a commit. So if you say git revert, it will already a commit as well. So what you need to do is to just push this up to the repository. Okay, if you check the log again, you can see that we have this some updates here, so this commit, but it is reverted. So all the changes we made in this commit will be reverted. So now the state of this branch at this commit is the same as was at this commit. Let's check this on the online. You can see if you go into the main branch and check the commits, you can see that we made this some updates commit, and then we reverted all the changes that has happened here. So just to wrap it up, Git is a powerful version control tool, a version control application, a nice command line tool to keep track of your code changes, and it's relatively easy to use and learn at least the basics. This was a first introductory video of how you can manage your code and how version control systems work. Maybe in the next video we can go deeper into how Git and all other version controls work.